live? All right, we are live. Hmm. So we were doing this. All right. So I think we were at AutoGrad. We have instantiated our policy over here. We were at AutoGrad, cell 34. And I think, no, I think we were even before this. One second. Okay, class actor critic. Instantiate policy, class actor critic, and then we have instantiated the policy over here. Observation is 256.24 and action is 256.7. Autograd. Now, autograd is one of the most important parts of PyTorch. X is equal to torch tensor 3 requires grad true. Yxx2 print dy by dx is equal to what? X dot grad dot item. So this is like a differential kind of function. That's what autograd does. I think we should. Oh, automatic differentiation. It's machinery that computes gradients derivatives for you so that you don't have to work out calculus by hand every time you build a neural network. When you train a network, you need to know if nudge this weight up a tiny bit. Does the loss go up or down, and by how much? That's a derivative. Okay, with millions of weights computing All of these by hand is impossible. AutoCAD does it automatically. It builds a graph while you compute. Every time you do an operation on a tensor that requires gradient, dot tensor requires grad true. Y is equal to graph is y to the power x by x to the power 2 y dot backward AutoCAD compute dy by dx 2x and x dot grad tensor 4 correct since 2 into 2 is equal to 4. I see. Okay. So AutoGrad is just a function for differentiation.
Yes, autograd is a function for differentiation.
Tensor 4, yes. And where is it doing grad over here? I got backward. Dot tensor 3. X 2. Okay, so 2x 6 divided by dx is 6. So do you understand why and where we are doing the differentiation in this?
We are doing differentiation while we are back propagating.
And why we are like back propagating is basically to check if I put the value of a particular node, is the graph going up or down, right?
Yeah, like not in that manner, but what it does is, so whenever we have, like the gradient descent we have
Yeah,
gradient descent.
yeah, yeah.
So right, for that, when we start like going in a certain direction, so we might go in a wrong direction, right? So whenever we go in a wrong direction, we will back propagate to make to the values that we calculated, right? So we are going to do a differentiation, and then we are going to use our autograd to redifferentiate again the same values that we have.
Okay, wait. Gradient descent is the optimization algorithm that actually updates your weights. The goal, find parameter value that minimize some loss function. Okay, the idea is simple. Imagine standing on a hilly landscape where your position is theta and your elevation is the loss. You want to get to the bottom lowest loss. You can't see the whole landscape, but you can feel which direction is uphill. Right where you're standing. So your the strategy is figure out the uphill direction, then step in the opposite direction. Repeat until you're at the near bottom. Okay. The gradient, the loss with respect to theta. This is a vector pointing in the direction of the steepest increase of the loss. So negative of delta theta L. So we go the opposite way toward the steepest increase. The learning rate, that is how big a step you take. Too big and you overshoot, bounce around. Too small and training crawls. Hmm. Oh fuck. So what does this exactly mean? Like this symbol exactly, what does it mean? This inverted triangle.
That's differentiation.
This is differentiation. Are you
Yes.
sure?
Yes.
So differential of theta L.
Yes. Like as I know, it should be differentiation. You can ask them.
Wait. Bro, this fucking music is so disturbing. Fucking assholes. Okay, gradient descent is optimization of the yeah mathematically theta minus n delta theta L. Delta theta L, the gradient of the loss with respect to theta. This is a vector pointing in the direction of the steepest increase of the loss. Differentiation of the gradient comes from the gradient. With respect to robot policy training. Your robot has a neural network brain policy that looks at what it's sensing, maybe camera images, force readings, joint positions, and decides how to move to insert a peg. Right now, early in training, this brain is basically random. It has no idea what it's doing. It might push the peg sideways, spin uselessly, or ram it into a wrong spot. Differentiation simply. Differentiation just answers one question. If I tweak this, if I tweak this one little knob in the brain slightly, does the robot's performance get a tiny bit better or tiny bit worse? Every connection inside the neural network is a knob. There are thousands of millions of them. Differentiation is just the math for measuring for one single knob which way to turn it and by how much it matters. Backpropagation simply. Here's the problem: you have million knobs and you need to know the right nudge for every single one of them. Every time the robot tries something, doing that one knob at a time from scratch would take forever. Backpropagation is a clever shortcut. The robot's brain is built in layers, like an assembly line where sensor data comes in one end. Backpropagation is a clever shortcut. The robot brain is built in layers, like an assembly line where the sensor data comes in one end and gets transformed step by step, and then action comes out of the other end. Yes. After the robot tries something and you find out how well or badly it did backpropagation, backpropagation works backward through that assembly line layer by layer, figuring out each layer's contribution to the mistake and reusing the work it already did along the way. So instead of million separate slow calculations, it's one efficient sweep backward through the network that tells every single knob, here's how much you contributed to the error and which way you should go. Gradient descent simply. Okay, so back propagation, I finally understand what it is.
Mhm.
Works backwards through that assembly line. Sensor data happens step by step, and an action comes out the other one. After the robot tries something and you find out how well or badly it did, back propagation works backwards through that assembly line, layer by layer, figuring out each layer's contribution to the mistake. Figure out each layer's contribution. One efficient sweep backward. Okay, gradient descent simply. Now that you know for every knob which way to nudge and roughly how much, gradient descent is just the rule that actually does the nudging. Turn every knob a small step in the direction that reduces the mistake, then let the robot try again. It'll do slightly better. Nudge, try again, nudge again. Okay. Do this thousands of millions of time and random. Clumsy policy slowly turns into reliably guides to the peg to the hole. Putting it together, robot attempts peg insertion. It gets some feedback how well it did, reward and loss. Back propagation sweeps backward through the brain and figure out how much each knob contributed to that outcome. Differentiation is the underlying math trick that makes each of those individual. How much did this knob matter? Calculation possible gradient descent takes all those answers and actually turns them the knobs a small step a time towards a better performance. Repeat this whole cycle over and over, and that's what training actually is. That loop: try, measure, blame, backward, nudge the knob, try again is the entire engine behind how your policy goes from random flailing to a smooth, reliable peg insertion behavior. Okay, and the idea is simple. Where a position is theta, your elevation is the loss. You want to get to the bottom, lowest loss. You can't see the whole landscape, but you can feel which direction is uphill right where you are standing. So the strategy is figure out the uphill direction, then step in the opposite direction, repeat until you're at or near the bottom mathematically. The gradient of the loss with respect to theta, this is vector pointing in the direction of the steepest increase of the loss.
What the fuck?
Muted, brother.
Muted.
Telemarkios. Okay, the gradient of the loss with respect. Steepest increase of the loss, so we go the opposite side. The steepest decrease. Neither running how big a step you take too big and you overshoot, bounce around too small in training crawls. Per batch one step. Gradually you walks down until the last step stops improving much. Differentiation where the gradient comes from. The gradient is just a bundle of partial derivatives, one per parameter. If I like this one weight up a tiny bit, how big does the loss change? Here's the connection. A neural network is a long chain of nested functions. Layer 1 feeds layer 2 which feeds layer 3, etc., all the way to the loss. To get dl by d theta for a weight buried deep in layer 1, you need the chain rule from calculus. Backpropagation is just the chain rule applied systematically. Backpropagation is just the chain rule applied systematically. Backpropagation is just a chain rule applied systematically, starting from the loss and working backward through the network layer by layer, using intermediate results instead of recomputing them from scratch every parameter. That reuse is the whole point. It's what makes compute gradients for millions of parameters computationally feasible instead of interactable. Differentiation, the math rule, okay, by an efficient algorithm, chain rule applied layer by layer backward for computing all those derivative across a deep network at once. The software that automates back propagation or builds a computation graph applies the chain rules for you when you call dot backward. The algorithm that uses those derivatives to actually update theta step by step toward lower loss. So the full pipeline, each training step looks like forward pass, compute loss, back propagation, forward pass, compute loss. Okay, so the forward pass and then compute loss, then back propagation autograd chain rule computes dl by d theta for every weight, gradient descent using those derivatives to step downhill, repeat, tying it to your peg insertion work, or tying it, sorry. When PPO computes its clipped surrogate loss, you call dot backward. That's the backdrop. Oh, sorry, that's the backprop propagation running the chain rule through your entire policy network. Through every ELU, every matmul to produce dl by d theta, your optimizer, probably Adam, which is gradient descent with momentum and per parameter adaptive learning rates, then takes those gradients and actually moves theta, the descent part is while loss curves and downward overtraining, you're mechanically walking downhill on the loss landscape one batch at a time. It makes sense to me now, but it is still a little.
So this thing only happens when we have, so this thing happens multiple times when we are generating our outputs for our inputs that we are putting in. So do you know what's a forward pass and what's a backward pass?
I've studied it, but I don't remember it.
Like, okay, if you're moving from input to output, that's a forward pass, and if you're moving back from output to input,
That's backward pass.
that's what happens multiple times based on our algorithm that we have put in.
Yeah. Okay, these are the two tools that he described. Forward pass, this is a robot actually doing something, running its brain in the normal direction, start to finish, sensors read the data, camera image, joint angles, force reading. This is the input. That data flows forward through the network's layers, one layer, one after another, each layer transforming it a bit more. Out the other end comes an action move gripper this way, apply this much force, the robot executes it, and you observe what happened. Did the peg get closer to the hole? Did it insert successfully? This gets turned into a number, the loss or reward, which basically says how good or bad was that. Hmm. You observe what happened. Did the peg get closer to the hole? Did it insert successfully? This gets turned into a number. Okay, that data flows forward through the network's layers one after another, each layer transforming it a bit. Out of the other end comes an action move gripper this way, apply this much force. The robot executes it and you observe what happened. Did the peg get closer to the hole? Did it insert successfully? This gets turned into a number, the loss or reward, which basically says how good or bad was that. So forward pass is equal to information flowing input through the brain, output is loss. It's the network thinking and acting left to right. So for information flowing input through the brain, output loss. Okay, so forward pass is something that calculates the loss. And then the backward pass, this is
Start
where you go. Okay, this is where you go find out who's to blame for the loss and by how much. Flowing in the opposite direction, start at the loss, how bad and was that number, wait, walk backward through. the same layers you just went through, but now instead of transforming data, you are computing how much did this layer contribute to the mistake. This is called backpropagation. This keeps going backward layer by layer until you reach the very first layer. At which point, every single knob, every weight in the entire network has been assigned a number saying this is how much you contributed to the error and which direction you should move to reduce it. So backward passes blame gradient flowing loss back through the brain all the way to the input side. This is where backpropagation and differentiation actually happens. The backward pass is the chain rule being applied layer by layer. Why both are needed together? You can't compute the backward pass without having one done a forward pass first. You need to know what the network actually did and how wrong it was before you can assign the blame. You can you can't improve the network with just a forward pass. You know how badly it did, but not which knob how to turn fix not to fix it. So forward pass, okay, one training step end to end, sensor data, layer one, layer two, action loss gradient, layer two, layer one, knob updates, okay, gradient descent, nudge every knob a small step using its gradient. Then you throw the robot at the peg again and repeat forward, backward nudge the thousands of times, which is what training the policy actually consists of under the hood. Ah, I see. So this is the actor. So how are we in the code? How are we assessing how like what was the action done? Like let's say we have the actor, right? We have the seven numbers. Where did it go? Self dot actor and then sequentially 128 action dimension and then tan h. What is tan h?
Yo, what happened?
Oh my god.
Yeah, tan
Yeah.
is a trigonometric function similar to we have, right? So
I know tan h is trigonometric, but
it's still gonna go from -1 to 1. That's what it means.
sine constant, that's the one, right?
Yes, yes. So it will go from
Hmm.
-1 to 1 as I
I
read.
miss those days, bro.
Oh my god.
Sine theta upon cos theta is equal to tan theta.
Yeah,
I remember this.
nice.
And then 1 by tan theta is equal to cot theta.
Mm.
And then I think cosec theta is 1 upon sine theta. And sec
Okay.
theta is 1 upon cos theta.
Nostalgia. It's hitting nostalgia, brother.
Trigonometry, brother.
Crazy shit. What was the
E
CGPA in 10th? 10?
8.8.
Oh, damn, bro. I had the same.
That's why we're same, bro.
Yeah,
Same FSU.
8. But dude, I fucked up my 12th. But yeah.
My 12th was decent as well. I
No.
got 86,
Oh my god. No. I fucked up my
which
12th.
was very good for according to my parents because they had very low expectations from
Hmm.
me. What was your 12th? 70?
Less than that, brother.
60?
7.
67?
Yes, brother. I fucked up real.
Were you preparing for IIT?
I don't know what I was preparing for. I don't know what I was preparing for, bro. I don't know.
Damn. But the fucking thing is, I got 86. My chemistry was 95.
Oh,
Chemistry was 95. Maths was 81. And
nice.
fucking physics was 71. This shit fucked my whole result.
Hmm.
Because my PE and my English was 90 and 90.
Nice.
90 and 91 or something. And this shit physics, fucked up my whole result.
Hmm. Yeah, I think physics was really hard. Well, maybe. Oh.
I don't know, bro. Like, I think that my year when we gave the exam, there was a strike or something about after the physics paper. They were like, this paper was too tough or something like that.
Mm-hmm.
And I was so confident in physics. I was not at all confident in chemistry. And I scored the most in fucking chemistry.
Hmm.
I don't know. 12th, bro, my cousin, he is going to be giving his IIT exam next year.
Oh, nice.
And I'm pretty sure he's going to get into an IIT.
Wow, that's great. That's just great, bro.
Okay, so I got this. Okay. Did we instantiate the policy? Okay, we instantiated the policy.
Predict job, predict state distribution, model dot distribution.
Bro, I don't. Let's ask Claude. Fuck it. I'll be back, bro. 1 second.
Mm-hmm.
Yeah. Okay. So this is the main actor critic neural network implementation.
Mm.
Actor critic def init. So this is the class and this is the parameters. Super dot init, self dot actor, nn sequential, nn dot linear, observation dimension 128, and the observation is 24. So 24, 128, loss function, 128, 128, loss function, sorry, activation function, nn dot linear, 128, action dimension, which is going to be 7, and nn dot tan h. Uh, and then self dot critic is nn sequential 128 with which has critic dimensions. Okay,
Yeah, it's -1 and -1 to 1. Yeah, I was correct. Okay, yeah, this one.
what -1? This is 61.
No, dude, the 10h function, like what it does, so it brings the value between -1 to 1. Like any values that are greater than 1 or -1 gets eliminated.
Uh, oh,
Right, so it's gonna give you,
any values that are greater than 1 or -1.
yeah, like it's not eliminated. Like basically, when you pass on your vector, your neurons from this layer, it's gonna bring
Oh, basically, I think graph.
just do 10h, just do 10h.
I know graph tan tan
H.
x.
Not do, don't do x, dude. Don't do x. Do h.
Bro, it's the same thing. It's just a variable.
Okay, what is the same thing over here?
Yeah, like -1 to 1, right?
Right, yeah. Where is this -1 to 1?
This is
This
minus
is
one
parallel bound, I guess.
tangent function x.
What is no root sign? It's the theta is something else. Trigonometric. This is the trigonometric function, but not like complete in that manner. That's why I was saying to do 10h. There's an equation that goes inside it. Do just do 10h. That it's gonna pop up. If you do just 10h, it's gonna, yeah. There we go. Yeah, one, two, three. Third image. It has the formula. So that is the formula for 10h.
Okay, so model is equal to actor critic to device. This does two things. Actor critic calls the classes init, which constructs two separate parallel neural networks inside one object. An actor network, the policy takes an observation and outputs the parameters of the probability distribution over actions, typically a mean vector plus either a learned or fixed standard deviation for a Gaussian policy. A critic, the value function, takes a possibility different larger observation and outputs a single number estimated value of that state. No, bro, I need more simple language. Step one, what's the robot brain made of? Your robot has one brain, but it's actually made of two separate parts that do different jobs. Actor is the part where it decides, okay. Robot senses and picks an action like move the gripper this way. Critic is this the part that judges how good a situation is. It doesn't pick action, it just looks at the current situations and says this looks like it's going well or this looks bad as a single score. Think of it like a student, the actor taking a test, and a tutor, critic watching over their shoulder saying you're doing well or this isn't going well. The tutor doesn't answer the questions, just judges the situation. Think of it like a student, the actor taking it as a tutor, watching over their shoulder, saying you're doing well or this isn't going well. Tutor doesn't answer. Okay, step two, what is the actor? Act randomly, not just pick the best action, only in the action. And the best move is guessing. So instead of picking one fixed action every time, the actor outputs something more like I think the move should be roughly this, give or take this much. I know that. The fuck? An actor into a policy. Oh. Both are just stacks of nonlinear layers with activations, ELU, RLU, whatever you're using in between. The knobs from earlier conversation are the weights in these layers to initialized randomly at this point. 2.2 device moves every one of those weight tensors onto the GPU or CPU. So computation happens here or there. Okay, this doesn't change the architecture. It's purely about where the numbers physically live in memory. At this point, model exists but hasn't processed any data yet. It's an empty-headed brain with random knobs. OBS is equal to env dot observe and critic. OBS is equal to env dot critic state. Your simulated robots produce two observation vectors from the current environment state. OBS, what the actor sees in sim to real work. This is deliberately restricted to what a real robot sensors could plausibly provide: joint position, camera feature, force, torque, etc. This is your OT from earlier. Two observation vectors from current environment state. The simulated robot produced two observation vectors from the current environment state of OBS equal to env dot observe. What critic sees. In robotics are specifically, especially asymmetric actor critic, common and sim-based training is allowed to include privileged information only available in object pose, contact force, friction coefficient, etc. This isn't cheating for the actor since the critic is only used during training to estimate value, not at deployment. Okay, this is why you have two separate observation calls. Actor and critic literally see different things. Distribution, model distribution, OBS. This runs a forward pass through the actor network policy only. This is why you have two separate observation calls. Actor and critic literally see different things. Distribution equals to model dot distribution or OBS. This runs forward past through the actor network. I'm not able to understand this, bro.
This part, bro.
Like, what is over here in code?
Okay, well, you know what? Just ask it to visualize it. That would be much better. Create an artifact and visualize it.
Hmm.
That would work. It's like more. It's a lot of text, right?
And what's next? This is still autograd, simple gradient. Fuck me, bro. Hmm. Here's the actor critic forward pass with real numbers plugged in, walking left, actor right, critic side by side. Bro, this is what it visualized. I also can visualize this.
Okay, so what was the part that you were not able to visualize?
Bro, basically what I'm trying to understand over here is like when we initialize this policy, right? We call model, we set actor critic dot to device. And basically what the output of this actor critic class is going to be. I'm
Mm-hmm.
not able to understand what's exactly the output going to be over here.
Mm-hmm.
And how are those values stored into this observation OBS?
Or go
And
down.
how huh?
Hmm. Okay, yeah, let's go through. Okay, so can you scroll a bit up?
This
Yeah. Okay, this is the class, and we are initializing the class, right? Let's go down. Okay, distribution. Go till the end. Value model of the actor critic dot to device model, and then go down. Yeah, stop over here. Yes. Observation env dot observe. Where is the model? Okay, model dot distribution observe, and then sample. Okay, so we have observation env dot observe. Where is this env coming from right over here?
that is what I'm not able to understand, bro. That is what
Yeah.
I'm
Okay,
trying to
okay.
understand.
Go up, go up. Go for it.
Yeah.
Go up a bit
There is
more.
no output for env.
No, so that env is a definite there's something that you defined up over here somewhere. Go up, go up, go more up, go more up. Yeah, I think it's on.
env dot observe.
Yeah, okay, do a command F on env. Do command F. Let's see how many checkpoints. Yeah, go up. It should be defined somewhere. Env.
Where is it?
What
Do you
is
see it?
first? Okay, go down. No, no, like, or okay, select the next arrow. Yeah, do again. One. Okay, wait.
Where the fuck?
Okay, let's do next. We'll see.
Yeah, nummy envies.
Okay, now do one more time. We'll see. What is there we go. Okay, class E, and we know this is not the one. Yeah, do more. Let's move to the one. ENV. Where is ENV over here? Next, 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 next.
Wait. Oh, env.
There you go.
Toy bag insertion env.
There
Nummy
you go.
envies. Device
So if you okay
log
now
20.
wait, I will tell you where is that observe coming from. So this toy peg insertion that you have, okay?
Yeah,
No
this.
class.
What?
This toy peg insertion has an observe method. If you search, no, you have to search toy peg insertion. Where is this class defined over up above?
Yeah.
Right. Now scroll
Class toy bag insertion.
down. It should have an observe class method. Go down.
Def in it. It doesn't have any.
Wait, it should go up. No, it's not correct then. Go up. It should have it. There should be something that will.
No, bro, there's only def in it.
No, self dot join. Go down. Search observe. Search observe. Observe.
Self dot observe. Self dot observe.
Yeah. Okay. So self dot observe, right? So
Oh,
all
yeah, def observe.
this is the class that is doing that. So now if you take a look at the observation, it's gonna concatenate the self dot joint position, and that's it's gonna divide it. So it's gonna create multiple tensors. So so each tensor will have individual vector that is gonna be for joint position, velocity, positional error, peg rotational error, and then we are using clamp over force. That is that the force should be minimum, so minimum should be minus 40 and maximum should be 40, and
Uh-huh.
whatever the value we will have will be divided by 40 as well. And then later, after that, we have insertion depth. So when we use observe, these are all the things that is happening in the background, right?
Mm,
All of the things that are being passed by our toy, the toy class that we are using,
mm.
right? So this is how we like backtrack. So now if you now let's take a look at where we were in distribution, right? We were around distribution somewhere.
Yeah, over here, OBS is equal to ENV
Now
dot
we have
observe.
model dot actor.
Oh, sorry. Model dot,
Yes,
yeah,
right.
model actor critic dot device.
Now, so what this dot to device does is it's gonna move it to the matrix multiplication
GPU.
to GPU, right? And then
Yeah.
we are gonna use observe to observe our observations and then create a tensor out of it. So whatever the output will be, the output will be a tensor of shape one, 2, 3, 4, 5. Five. Okay, so it should be of say shape 24, I guess. That is
Mm-hmm.
the shape of that tensor. And then we
Mm-hmm.
have critic job. So there should be another method that will describe what does this critic state mean. And once we have that, so we are going to pass our observation inside our distribution. We are going to use our
Mm.
actor critic class and pass on our values into the distribution. So now let's take a look at the code. What does distribution does over here? What
Distribution, this.
Yes, what is distribution doing it or doing over here, and how is it doing it? Oh,
Oh, I think I saw. Yeah, def distribution mean equal to self dot actor. OBS STD. I think distribution is, yeah, calculating standard deviation or something.
yes, right. So standard
Yeah,
deviation of what? What are we calculating the standard deviation of? That is
on
going to
the
be what?
Gaussian policy, I guess. Standard deviation of the actor observation tensors.
So what is actor doing uh, over here?
Actor is basically the, what do you say? The seven values that are going to perform the robot action.
Oh, okay. So we are going to take the mean of all the values and wrap
Yeah.
it into a tensor.
Hmm.
How does that work?
Okay, over here. Let's see this now. So we know this is the part decides what to do. This is the part that judges how good the situation is. It doesn't pick action. It just looks at the current situation and says it looks good. Well, this looks bad. Single core. As a single score, think of it like a student actor taking a yeah judge. Why does the actor act randomly and not just every training is guessing? I think move should be roughly this, give her this, then randomly pick something in the range. I think the move should be roughly this, give or take this much. This is something randomly in the range. And let's explore, try slightly different each time rather than getting started with untested, more confident, give or take shrinks and consistent. This is a robot specific trick. In simulation, you know everything exact peg position, exact hole position, exact friction forces, all of it. But a real robot in the real world can't see all of that perfectly. It has its actual sensors, camera joint encoders, so the actor is only allowed to see what the real robot could realistically sense, because that's what it'll have to work with once you deploy it in the hardware. But the critic, which is only using during training to help judge how well things are going and gets thrown away afterward. But the critic, which is only used during the training to help judge how well things are going and gets thrown away afterward, is allowed to peek at the cheat sheet, the full perfect simulation state. It does not. It's not cheating because the critic never controls the robot. It just helps train the actor better. Now let's connect to see the code piece by piece. Model is equal to actor critic dot device. This builds two brains, actor plus student, critic plus tutor, described above with random untrained knobs, and put them on the GPU to the math. So the math runs fast. OBS is equal to env.observe. This grabs two versions of what's happening right now. OBS is limited, realistic view the actor gets, like real sensors. OBS is equal to env.observe, and critic observe is equal to env.critic state. Is the full information cheat sheet view of the critic that critic gets. Distribution is equal to model distribution OBS. The actor looks at OBS and produces it's roughly this, given give or take this much guess, packaged as a probability distribution rather than one fixed number. Action is equal to distribution dot sample. The robot randomly picks an actual action from the range. This is exploring guessing step.
Bro, you know my dental insurance pays two like free like covers two free cleaning.
Uh,
Hmm. I didn't know that. I gotta
I
look.
am also I also get I have that MetLife dental insurance
Mhm.
and I'm eligible for whitening and everything every 6 months.
Oh, for
But
free.
there's a catch.
Wow.
The catch is like you can get the whitening for free, but like when you go the even with your cleaning, bro, there I'm sure there's gonna be a catch that it's gonna like I saw that on Reddit
Mm-hmm.
that you go for the cleaning, but they're gonna charge you the consultation fee.
Oh.
Yeah, and
Oh.
that free cleaning is only eligible on if you agree to visit the office every 6 months, where they're going to charge you the consultation fee.
Oh.
So that's the scam, brother.
Hmm. I think.
Because I keep getting my email about there's this dentist office.
Hmm.
They're like, oh, you have a free whitening and cleaning and all that shit.
Hmm.
Yeah. And if you want to get white, like teeth whitened, just buy this.
What?
Hi, smile strips,
Oh. They work.
whitening stream. Yeah, they work. I've used them.
Oh. Okay. I'll get them. So you'll like use them and sleep. That's how it
Like
works.
you can use them every once a month.
Oh. So like
You don't put it
how does it
what?
work?
You put it like this for like 30 minutes and then you take it off and it just works.
Hmm. Okay, I'm gonna buy it. I'm
Yeah.
gonna buy it.
Yeah.
Yeah. Yeah. But yeah,
It's a
like,
hassle to use a little bit, but
I
it's
know it's
okay.
a hassle. I know, I can see it. But like, if
Yeah.
I have to do it once in a month, that's fine.
Yeah. Yeah. But it doesn't stay. Like the whitening doesn't stay. It it's basically whitening. So when you get it at a dentist's office, that will also fade away after like a month. So this is like they recommend to do it like every once a week,
Mm-hmm.
but I can't do once a week, bro. I don't do it once a week.
Oh, okay. Hmm. Fuck, bro. So, no, text.
Okay, so we have instantiated the policy again over here. Yeah, okay. The what's happening right now, OBS is the limited realistic view. The actor gets the real sensor, and the critic observation is the full information cheat sheet. Observation and critic observation. So this should have been actor observation. Fucking they don't name the fucking things properly.
Hmm.
Distribution equals to downward. The actor looks at the OBS and produces its roughly this, give or take this much guess packaged as a probability distribution rather than one fixed number. So this is what distribution is doing. I think this is look at this. This code distribution equals to model dot distribution OBS. So it's gonna take in the OBS values, run it through the distribution function of the model, and then model dot distribution observation. And the actor looks at the OBS and produces its roughly this, give or take this much guess packaged as a probability distribution rather than one fixed number. So action equals to distribution dot sample. The robot randomly picks an actual action from that range. This is the exploring guessing step. Value is equal to model dot value critic observation. The critic looks at the cheat sheet view and gives a single judgment score. How does the situation look? Print observation shape. Okay, just a sanity check that may. Oh, now I get it. So the seven values, out of which six are observation given by the actor, and one is the critic value of how good the value is. Based on this, bro, you remember this our diagram for the oh, no, I think it was this. This. No, this is I think. But now I get it. The values. Yes. I get it now. Instantiate policy. And then autograd is getting the loss gradient backwards. Now OBS is equal to gain dot observe output model dot actor observation fake loss output dot square dot mean model zero grad fake loss backward first parameter is equal to next model dot actor parameters print parameters first parameter grad dot shape print first parameter dot grad dot abs dot mean. Gradients through neural network. Okay, now I get it. Um,
Wow.
okay, I think I got it. 6 numbers, actor observation by critic. So total. Is that correct?
Six, 6 feet numbers are possible chunks of our after observation. So what's a critical output? It's saying the 0.72 in the example is a critical output.
One second.
Anything you think you to search for.
Allegheny County.
Oh, dude, how's your light doing?
What
That
light?
the book light that you bought.
Yeah, it's doing good.
Yeah. Oh, okay. Because I just found a good product for you that does the same, but it's more sleek and it's rechargeable and all that shit. And it was like $6. So
Nah, mine is good.
good. Then good. I'm planning to get an iPad or a Samsung tab. I'm just confused.
Bro, don't get a Samsung tab. Get an iPad if you're trying to get one.
Yeah, I was trying to go out, get out of the iPhone ecosystem, but I think I was.
Why? Why?
I don't know, man. I feel like okay. Oh,
Give me one good reason.
I don't have any reason. It was just a random thought.
Hmm. Okay. The computation graph was weights linear ELU. Yes, action loss. Loss dot backwards.
But I fear that if I get a iPad, then I will stop using my MacBook.
What?
Okay, bro.
Cloud code.
Yes, because
I don't think that is gonna happen.
dude. Okay, so my thesis is since I have like all the compute and everything on the cloud, why
Yeah.
would I need a MacBook at that point
Mm.
to manage everything out? Like I can get a decent keyboard for my iPad, and like I can just carry a small tablet or iPad everywhere else. Or
But why do you want to do that? Like, how are you like? Are you traveling that much?
I don't know, man. Like it was just a thought. Okay, why do I need to do that? It's not the question. But I was like, I might if I get an iPad for sure. I might think that okay, this MacBook is gonna stay over here all the freaking time. And if I'm going to
Mm-hmm.
any meetings or anywhere, I'm gonna use that iPad
Mm-hmm.
all the time.
With a pen.
Yes.
Yeah, let me note that down in my $1,000 iPad.
And they're like, fuck, oh, fuck this guy. Oh yeah, oh something is down. Oh wait, let me pull up my iPad and then let me ask my agents out. What's up, boys? What's up? We doing good? But yeah, I don't want to spend like I don't want to spend my $1,000. I might get a refurbished one, like M4 M something like that, if it has.
I was also thinking of getting one,
Yeah.
but I won't. Milwaukee Tool Party live. Crazy deals.
What the fuck is wrong with your feed? I don't know. Do not get these kind of feed.
Bro, I don't use it at all. Which is the best one right now?
M4 M5.
No, like which
Nano texture uh, iPad for like $1,000, and it's a terabyte version, and that's like cheap. But I guess I can find a better deal as well.
iPad Pro 11 6th Gen M5 256 gigs
And
Wi-Fi Black
there's a deal going on
eBay.
as well that you can get M5 on boot. Yeah, Citizen. Yeah, it's fucking 849. Holy shit! I want to have like at least 512 gigabits.
Get this one, bro. iPad Mini 6.
But it won't be usable at all.
Why?
First of all, it has bezels, and the chip is pretty
So
old.
what?
Yeah, I don't like bezels, bro. I don't like bezels.
Bezel-less.
Yes, brother. Life needs to be bezelless. Bezels. Bezels.
This is also good deal. Apple iPad Pro 6th Gen 256 gigs.
Yeah, bro. Oh, yeah, that's a sweet deal as well. Sixth gen. I think it won't have that chip, but no worries. We'll see, bro. We'll see. All right, let's get back to it. Too much distraction. We'll see if my budget allows.
But why the fuck do you want an iPad? I don't get it.
Oh yeah, that also. I don't know. Like I think I need an iPad for.
Just for the fun of it, bro. I don't.
I don't know. That's why I have. I'm thinking. That's why I didn't do like. I did not do an impulse purchase at that point. Like, hey, let me get this
I
done.
think you should consult the one and only before doing anything like that.
I know.
And he will talk some
Like,
sense to
bro,
you
you can invest that money and.
and lose that money.
No, what I will do is I will invest $1,000 in Apple instead of buying an iPad. And
Yeah.
when I'm going in the flight, I will look at that Apple stock and see that there is my $1,000.
Exactly.
Yeah, that's what I will do. No, thanks. Okay.
Okay. Bro, I think we should move to our synthetic data project now.
Okay, bro. Our Tigers uh,
What,
GF is gonna come soon,
bro?
and then
I'll,
Lioness. No, what Tigress? What do we call female tiger?
bro, let it be. Let it be. I don't wanna
Okay.
let that.
Let's not do it downstream. There's a person saying hi.
So, bro,
Hello, hello, hello.
that synthetic benchmark thing, bro.
This shit is taking forever to complete. My god.
It's gonna, bro. It's gonna.
Let's. Where was that? Basically, our project is complete, right? This project, because our training is complete.
Yes, the project is completed, but we do not have the complete understanding of the project. We have, we have understanding, but not like thoroughly.
Okay. Let me do one thing.
Hmm.
Uh, I think
What are you doing?
I'm trying to find what are the things that we need to understand by the end of this. From one documented command, checkpoints and configurations are versioned. At least three training seeds are completed. Reward component are individually logged. Training can be resumed from a checkpoint. Evaluation, nominal, standardized, and randomized seeds are defined. Every policy is tested on identical episode seeds. Per episode, results are exported. Success and force metrics are reported together. Common failures are categorized appropriately. Architecture diagram, results table. Okay. Can short horizon contact prediction improve recovery before jam occurs? Explain multiple. We need to create this video, bro. Show PPA learning curves and short montage policy. What is exactly NVIDIA's forge peg insertion task? Task? What is task?
Dude, task is the three things that they're trying to do, right? One of them was nut threading, and then one was that peg insertion, and then the other one
Oh,
was
peg insertion, yeah.
grew three. There are three gears. Gear meshing, yeah, gear meshing.
Yeah.
You are like stacking or maybe like merging multiple gears
What
together.
is peg insertion task in ISAC lab and ran a control 2x2 ablation to separate two things that force aware manipulation usually bundles together, giving the policy a contact force observation and putting a contact force penalty in the reward. Four policies, three seeds each, 500 PPO epochs per seed. Then all 12 checkpoints evaluated on the same 500 deterministic episodes. The observation is what lets the policy learn the task at all. It roughly doubles success over the geometry or only baseline. The penalty on its own without the observation makes things worse than the baseline. A policy punished for contact it cannot sense learns to avoid inserting rather than to insert carefully. The 3-minute version with the caveats attached had unprompted the three things a sharp reviewer will otherwise find themselves. Absolute success rates are low, 7 to 14%. Hmm. Oh, walk me through the 24-dimensional actor observations and defend each choice. Fingertip position. Why is there a seventh action dimension that is not a control output? The forges success prediction head, the policy output its own estimate of whether it has succeeded rescaled from -1 to 1, and the reward includes the absolute error against ground truth success. Its purpose is to give redeployed. How many questions? Experimental design and application methodology by zero
Like I
log
think 40, 40,
40, bro.
40,
40.
40,
Mm,
40, 40, 40, 40 questions. You know for how much? 40 questions.
Stop it, man.
40. full party scene, bro.
Yeah, man, this fucking
Dude, I'm
so
getting a fucking Chromebook with 100 and oh no, it's 128 gig storage. My bad, my bad, my bad.
128 gigs for a Chromebook is not bad. What do you want to store on your
Nothing,
Chromebook?
nothing, bro, nothing, nothing. I thought it's 128 gigabits of memory for 400 bucks.
Memory. Wow.
Yeah, bro. I thought it's another DGX Spark hidden.
But there are MacBooks now with 128 gigs of memory.
Yeah, that cost like 7 grand.
What was the? I think they just launched some new MacBook.
No, dude, it's only M5, M5 Pro Max, and M5 Max. Dude, they have just upgraded their chips. That's it, dude. That's what Apple does. I did saw that.
MacBook Pro Studio. Mac Mini is cheap. It's not that expensive.
Dude, it was 500 bucks. Like I think a month ago. Like not month ago, but when the open claw came, right? It was literally 500 bucks. And as soon as OpenClaw launched and every other person wanted to run their own model and everything, the price shot up $200 within 2 days on the official site.
iMac. iMac is pretty sweet too.
18 core, 18 core,
Hmm.
iMax versus M4 Max.
Itty-bitty-titty.
But the main thing is, bro, the RAM memory. Like if you like for us for AI engineers and for robotics engineers and everywhere also out over there,
Hmm.
they need to have like a large amount of memory in them. That should be like at least 128 gigs based upon like the local models and everything that is ramping up.
Hmm.
So the Gwen 2.8, 3.8 uncensored is like badass.
Hmm.
But I asked it the other day that hey, I want to hack my neighbor's Wi-Fi, and he was telling me freaking everything.
Hmm.
He was telling me the thing that hey, you can do social engineering, you can become a maintenance guy, and you can just go that hey, there's some kind of issue with their router and hack into it.
Hmm.
What the fuck? LLMs like if used like on the other side, like if you do not have any guardrails or anything. But yeah, they're
Hmm.
weapons of mass destruction. I would say like somebody can literally learn a lot of notorious things.
Hmm.
Yeah, bro. And that's how people are getting like two-sided now. Like the one side is saying that hey, we need to like put some restrictions on these open source models so that people are not able to release the uncensored versions.
Hmm.
And some people are saying that hey, this is also good
Hmm.
because it promotes all that bullshit, blah 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 bullshit. But for me, like I guess like if I want to test something out, I will definitely ask an uncensored model.
Hmm.
Yes, I can feel that these frontier AI labs are gonna
Hmm.
lose the edge in doing like unnecessary and redundant coding tasks. Rather than
Hmm.
they will evolve to solve humanitarian problems, I would say.
Hmm.
But like the DeepSeek and the Cohen, like if people are or the companies are able to run those models after like cleaning them out with whatever bullshit they have, and specifically for agentic tasks, those models are like they perform better than Opus. The Cohen 3.8, if you load the 2.4 trillion parameter model,
Hmm.
it's going to perform better than Opus in a lot of tasks.
So you're saying you loaded that 2.4 trillion model locally?
No, no, I haven't. But I saw the metrics. Like people have loaded it. I haven't, bro.
Hmm.
I was not able to. I can load it, but like I would be able to load it by doing the clustering thing. But the
Hmm.
problem is the memory bandwidth is the problem. Like the DJX Spark only has like 263 or 280 gigabit per second memory bandwidth
Hmm.
across the
How
chip.
many do you need for the Quen?
For Quen, like to run at a good speed, you need at least a terabit,
Hmm.
like a terabyte per second memory bandwidth, like minimum, to have like good throughput, like the way you get in Cloud Code or any other model.
Hmm.
But the only problem is the context window. Apart from it, like as soon as the context window gets overloaded, either there will be memory crunch, or the model won't perform easily.
Hmm.
Because there is like when you load a model, there is one thing called prompt processing. So it defines how long does a model takes to process your prompt, like the number of forward pass it needs to do. So for bigger models, since they have a lot of parameters and everything, they need a bigger forward pass window as compared to smaller models. And since they need a bigger window, they have a lot of neurons that are getting transferred between their memory and the GPU that is computing those tensors out. So if you have a larger bandwidth or a higher bandwidth, that is like a terabit per second or 2.5 terabit per second, like the H100 and the Vera Rubin that are recently launched, they have like 3.5. So they're like crazy fast.
Hmm.
Like at this point, like a gigabit right now, the connection that you have on your internet is
Hmm.
is I would say 200 times slower as compared to what LLMs need to process or transfer their data between them.
I see.
Like crazy fast, bro, crazy. Like you can download, I would say 200 or 300 GBs of movie or content from internet within a blink of a second, like this. That's how crazy fast it is.
I see.
Like downloading GTA 5 within a second.
Hmm.
You see book.
I see. Okay, I've started the artifact. What I'm gonna do is I'm gonna give that artifact to my fucking portfolio designer, and
Mm-hmm.
I'm gonna add that shit on my website.
Nice. Makes sense.
Come on, come on, come on. What is it trying to do? I'll be back. All right, let's start our synthetic data project. We can come back to this tomorrow now.
On step 3 now. Load a pre-trained object detection model. And we already did this. Input 3 into this frozen kina. इमेजनेट पर पहले से ट्रेन एजेस टेक्सचुअल शेप पहले से आते हैं. Okay. Let's go, bro. What the fuck are you doing? You're muted if you're saying anything.
Okay, so you did not heard anything about DGX Park and anything me saying?
No.
Fuck. Nothing, bro.
What were you saying?
Nothing, bro. I was saying let it be. Fuck. Fuck, I forgot that I muted myself. Okay, so we have our torch vision models. That is gonna be our detection.
We already did this part. Faster RCNN, we already know that 28.3 million total parameters and then 28.1 million are trainable.
Mhm.
Frozen N for N P P P P if not requires grad. So this is again that differential one, I guess. Requires grad. Oh,
Oh, it's ready.
yeah. What is not done?
Task registration, Sharia force, peg insert, VO4 from upstream, I stack forge, peg insert, direct VO proven tentacle under the same seal before any ablation code was added. Oh, you should not share this. So
Who's gonna have this link?
Proudpod has a bug. So whenever you share something, this gets reported on Google and gets so whenever if you type anything, there's a Google docking keyword. When you type cloud code AI and artifact all together, all the artifact facts that everyone has shared till now will pop up. Oh wait,
What? Where?
wait.
I don't think that's true, bro.
Dude, that was true, dude. That was definitely true.
I just searched Cloud Code artifacts in front of you.
Right? Oh, I will tell you what to do. Wait, let me just verify it once from my side because I'm trying to test that. Oh, they have removed them. Okay, dude, they have removed them, unfortunately. Earlier it was there. I did saw it. They have removed them. PPO clip, discount, value advantage, batching, reward. Base reward terms are inherited unmodified from factory. Forge and this work. Wait, bro, we were doing synthetic. We are now at four. What the fuck are we doing?
No, I'm just taking a look at that report, bro. It just opened, so I'm just. mm, Let me just see
Brother,
what the results look like. OD. What was OD? Jam
object,
rate and OD.
object. What was what did you do? It was wait. Oh
Out of distribution.
no, OD or something else. OD and robotics.
Bro, out of distribution, it is written here.
Where is it?
No out of distribution or jam detection signals exist yet.
Oh,
Success rate by policy. B succeeded the most. Mean nominal success rate over 3 seeds dot or individual. Dashed lines mark the baseline. Peak contact for the policy.
for a mobile manipulator trained in a clean lab.
Dude, do you remember what the guy's name was? Daniel, that AI or artificial intelligence professor.
I know shorts.
Daniel Schwartz. Mm.
Dude, you know, like, okay, fuck, dude, like, we are getting distracted. I don't want to not say about this.
What?
Nothing, bro. Let it be. Focus. We are doing too much distraction talk today.
Okay, we will take a look at this tomorrow now.
Mm-hmm.
Mm. Okay. फ्रोजन लिस्ट छोटी होगी और उसमें बॉडी कौन और बॉडी लेयर वन यही है उस नेट का स्टेम और पहला स्टेज Okay, bro, wait. I'll put a 45-minute timer and then
Mm-hmm.
1 second. I'm not distracted too much today. All right, the timer has started. 45 minutes. Come on.
Okay, let's go for TL.
Hmm. So we were on experiment. कौन से parameters freeze हैं खुद देखो. We already know what parameters are freeze.
Mm-hmm.
Backbone dot body conv weight. I don't know what that exactly means, but these are the frozen parameters over here.
Mm-hmm.
And then पहले लेयर्स सबसे जेनरिक फीचर सीखते हैं. एजेस, कॉर्नर्स, कलर ग्रेडियंट्स, ये चीजें सिंथेटिक और रियल इमेजेस में लगभग एक जैसी होती है, तो इन्हें दोबारा सीखने की जरूरत नहीं है. और वैसे एक सिंथेटिक डेटा पर खास है. अगर तुम ये लेयर्स अनफ्रीज छोड़ दो तो वो रेंडर के आर्टिफैक्ट्स पकड़ सकते हैं, स्पेसिफिक नॉइज, एंड दिस इज ऑल गोइंग टू कॉज ओवरफिटिंग, आई गेस. यस. ओके. एंड दिस इज गोना चेंज द ट्रेनेबल पैरामीटर्स. ट्रेनेबल लेयर्स बदल कर देखो. ओके. 40L in 0135 M build model num classes backbone trainable layers TL TOT sum P numel for P in M parameters TR sum A numel for P in parameters if P requires grad trainable layers. M trainable del M. TL बढ़ने के साथ ट्रेनेबल काउंट बढ़ता जाएगा. TL इज इक्वल टू 5 पर लगभग सब कुछ ट्रेनेबल. मेन फाइन ट्यूनिंग नॉब है. ट्रेनेबल लेयर्स 0 1 3 एंड 5 कब यूज करो. बहुत कम डेटा, 100 से कम इमेजेस, डिफॉल्ट सिंथेटिक डेटा के लिए अच्छा बैलेंस. TL is trainable layers. Okay.
Yes.
Trainable layers equal to TL TOT sum copy in M parameters. For TL in 0135 M is equal to build model num classes backbone trainable M parameters is equal to TL. So for in TL trainable parameters for 0 TR is going to be sum of P dot numel. What is numel?
I think it's a function, I guess.
Wow, I didn't know that, bro.
Like it's a mathematical function, and that's what I mean. It's a function means it's a mathematical
Uh,
function that does some kind of math. Like we have float 32 and pi, right? Similar kind of like that. We can directly ask PyTorch. Total number of elements. Dude, why are you doing numel in MATLAB?
bro, automatic.
PyTorch. Same in within a tensor. Okay, numel is number of elements. That is.
Let me see. Okay. What is this? Using the torch function.
Torch function? Where are we? We are using no grad. Where are you talking about?
This one, this one.
Yeah, so torch, tensor, numel.
What does numel do exactly? X dot numel is output is 6. But 6 means 1, 2, 3, 4, 5, 6.
Yes.
Like 6 elements total.
Yes, yes, total. No, it only counts number of elements in a tensor.
Mm.
Like all the elements that exist, I guess.
In the total tensor, okay.
Yeah.
And then X dot numel is also okay method works on complex multidimensional tensor tau dot zeros 2, 3, 4. Y dot numel output 24. Okay, because 2 into 3 into 2, 4. Oh,
You can print
but
Y to get it. Print Y, just print Y.
where below this?
Yeah, yeah, do that. Works. Go down.
Mm,
Oh yeah, there you
yeah,
go. 1, 2, 3, 4, 5, 6. So two, two. What the fuck? Two.
but this is not 24.
Root 1, 2, 3. Root count 1, 2, 3, 1, 2, 3, 4. Count number. How many number of rows and how many number of columns do you have?
Oh, 24 like told. Yes,
Yeah.
yes. Mm, so 2 this, 3 this, and 4 this. Okay.
First dimension, second dimension.
Complex. Okay, so this is how tau dot zeros is represented. Okay. So 2 basically means how many total grids, and then 3 is the number of rows, oh sorry, columns, and 4 is the number of rows. I kind of get it, but what is the use over here? So number of elements, p dot number of elements for p and m dot parameters if p dot requires grad. What the fuck? It's some crazy ass code. But let it be. Okay, what is the next walkthrough? Okay. Guide suggested fix a under train with numbing box or increase more of the backbone numbing. Hmm. Train mode का output ये सबसे important experiment है. Hmm. Okay, so this is the train mode output.
Loss objectness, loss asking in the box, loss classifier, loss box, red. RPN यहाँ कोई ऑब्जेक्ट Yeah, background.
लॉस ऑब्जेक्टनेस आरपीएन, यहाँ कोई ऑब्जेक्ट है या बैकग्राउंड? लॉस आरपीएन बॉक्स, ओ यहाँ कोई ऑब्जेक्ट है? ओ ऑब्जेक्टनेस, ओके ओके ओके, सो दैट इज बेसिकली डिटेक्टिंग if in the image that is a box or like just a background
Yeah.
pixels.
Hmm.
लॉस आरपीएन बॉक्स रेज प्रपोजल बॉक्स की पोजीशन ठीक करो। लॉस क्लासिफायर रोल हेड, ये पैलेट जैक है या बैकग्राउंड? ट्रेनिंग मोड में मॉडल लॉस का डिक्शनरी रिटर्न करता है, कोई प्रिडिक्शन नहीं। चार लॉसेस आरपीएन प्रपोजल बॉक्स की पोजीशन ठीक करो। लोन आरपीएन, लॉस आरपीएन बॉक्स रेज। लॉस ऑब्जेक्टनेस इज दिस, लॉस क्लासिफायर इज ये पैलेट जैक है या बैकग्राउंड। लॉस बॉक्स रेज रोल हेड, फाइनल बॉक्स की पोजीशन ठीक करो। ओके अब जब वो ग्राफ आएगा तुम्हें पता होगा हर लाइन का रिप्रेजेंटेशन रिप्रेजेंट करती है, और इसलिए स्टैटिस्टिक्स का ट्रेनिंग लूप इतना छोटा है। पूरा ऑप्टिमाइजेशन स्टेप बस ये है। लॉस डिक्ट मॉडल इमेजेस टारगेट लॉस सम, लॉस डिक्ट डॉट वैल्यूज। मॉडल खुद सारा लॉस कैलकुलेशन अंदर कर लेता है, एक्सपेरिमेंट डी इवैल मोड का आउटपुट। मॉडल डॉट इवैल विथ टॉर्च नो ग्राड out is equal to model torch dot rand 3 image height image width device is equal to device print keys List out 0 keys, print boxes, out 0 boxes, shape, top 5 scores, out 0 scores. मॉडल खुद सारा लॉस कैलकुलेशन अंदर कर लेता है. What the hell does that mean?
Dude, the loss is calculated using the auto gradient, right?
Yeah,
Right. So that's
yeah.
what it means over here. Model is gonna calculate the loss inside that loss function that you're trying to create. So this model over here relates to the main class that you created earlier. So go up, go up, go up. Where are you initializing the model? You have to look into that. So there is a point where you're trying to initialize a model, and that model has every thing for the loss function as well.
I think this one. Def build model, num classes, backbone, resonant, trainable layer, speed, chain, fast RCNN.
It should not be def build. It should be only model. Build underscore model is a different class. It's this one. Model equal to build underscore model. Oh yeah, yeah, that's the one. Yep, correct, correct, correct. Yeah. Backbone, and then okay, we are using faster RCNN already. So we are
Mm-hmm.
importing a library. That's why we do, it's hidden inside the faster RCNN architecture. It already has
Mm-hmm.
loss and everything.
It says over here requires grad.
Yeah. So it's checking in the so whatever model we have loaded, it already has the auto grad function and
Loss function calculation and back propagation.
yes. So that's why the model is already optimized. You do not have to worry about it. How it does that.
Mm-hmm.
So heavy lifting is already done by the greater researchers that published the AlexNet and then PyTorch.
Mm-hmm.
That basically wrapped it into a library or that we can directly import. More like
When will that day come, bro? When our work is going to be used like that?
one day, but the you have to sell it otherwise the market equity.
And what if somebody captures your idea?
That's why you should not ever publish it. Keep it yourself and take it to your grave and then publish it.
Okay. And then ट्रेनिंग मोड में मॉडल लॉस का डिक्शनरी रिटर्न करता है कोई प्रेडिक्शन की 4 लॉसेस. Oh, so this is the loss dictionary over here. यहाँ 4 कॉस्ट तुम स्टेप 6 का आगे अब जब वो ग्राफ आएगा तुम्हें पता होगा हर लाइन का रिप्रेजेंटेटिव. और इसलिए स्टेप 6 का ट्रेनिंग लोग इतना छोटा है. पूरा ऑप्टिमाइजेशन स्टेप बस ये है. मॉडल खुद सारा लॉस कैलकुलेशन अंदर कर लेता है. लॉस टेक्स्ट इज इक्वल टू मॉडल इमेजेस डाल. Eval mode output. So keys, boxes, labels, scores. So these are the 3 keys with torch, no grad. Model torch dot rand 3 image height, image width, device. Keys list out 0 keys, out 0 boxes shape. So boxes.
There are 100 boxes. I would
Where
say
do you see? Okay, 100, yes.
there are 100
And
boxes
what is this for?
with 4 elements in each index. Just print it, bro. Print boxes and you print boxes and then you will get it. Print boxes and then do until
But boxes is not defined.
root boxes. Oh, sorry, out, out, zero,
Yeah, out.
out, zeroth index, and then boxes. Wait. If you do out, it's gonna print a lot of things.
Dot dot
No, it's another matrix.
and
Do bracket.
big bracket.
Yeah, big bracket, inverted comma,
What?
inverted commas, boxes,
Yeah.
boxes. Yeah, invert and then close, and then do bracket, big bracket again,
Mm-hmm.
do colon, 10.
10.
Yeah, 10. Let's see. I think this should work. Print. Yeah, there we go. Bam.
What is this? But
So this is your box tensor. So as you can see, you have. So what would if you count the number of rows over here? It's gonna be 10, right? Since we
Mhm.
sliced it across 10, like 10 elements, and like the top 10, and then the number of rows columns we have is 4. That defines the shape of the matrix, or the size, or the shape that we printed earlier. So if you take a look, torch dot size, it says 100 comma 4, right? So 4 is the number of, we have 4 columns, 1 2 3 4, and 100 is going to be the number of tensor, like number of rows that you have in that tensor. So 1 2
Mhm.
4 right now, since we did until 10, we only got 10 rows. So I was showing
Mhm.
that how does that tensor look when you print it, and why, how does that shape relates to.
Top five scores, and then what is exactly this model function doing over here?
This model. So the model has okay. So when we computed everything, right? So we computed it under our object, or the mod, or the variable that we created. So model
Mhm.
defines the whole faster RCNN architecture, and that build under
Mhm.
the model class. So whatever is inside that model or that class gets inherited by the model, right? So the model can take in any parameter that it wants. So right now we are using model to, I guess, generate the no grad evaluation, and the
Mhm.
output is generated at the end. So we right now we are looking at the image height and the image width. But what the fuck? Oh, we are looking at the model output. Oh, we are looking at the model output, the final output it generated. That's what it means over here. The final output it generated once we ran the model.
Wait, a box is torch 7. Okay, n dot 4 n कुछ भी हो सकता है, जीरो भी मॉडल अभी अनट्रेंड है, रैंडम नॉइस पे जो भी लगे वही दे रहा है। ये इम्पोर्टेंट है, सेम मॉडल सेम सेल बिल्कुल अलग आउटपुट, फर्क सिर्फ इतना है। मॉडल डॉट ट्रेन मॉडल इमेजेस टारगेट टेक्स्ट फोर लॉसेस मॉडल डॉट eval और एक छुपा हुआ बोनस eval मोड में एनएमएस नॉन मैक्स ऑपरेशन ऑलरेडी लग चुका है टाउ वर्कफ्लो में। इसके लिए डीवी स्कैन क्लस्टरिंग स्टेप था, यहाँ वो मॉडल के अंदर ही है। तुम्हें कुछ नहीं करना जरूरी, एक्सपेरिमेंट खत्म करने के बाद मॉडल को वापस ट्रेन में मत छोड़ो या छोड़ो, कोई फर्क नहीं है। मॉडल eval एक अच्छी कोडिंग प्रैक्टिस है जो तुम्हें अभी अपनानी चाहिए।
So we have like, okay. So do you understand what does model.train do?
Returns dict of four losses.
So what is it doing over there? Why are we getting those four losses?
But where is model.train over here? I don't see it. This is
Above,
just
right?
model.
It's above in the above block.
Where do you see model.train?
Road above first line in that block,
Oh, model.train. Okay.
right?
Mm-hmm.
So once we have trained the model, we are going to evaluate our model, and then we are going to look at the output that our evaluation has generated. So when so how machine learning works is, as you know, that we have test set and training set. So first we are going to use our training set to test our model and train our model. And once we have trained our model, then we are going to use that evaluation function that we have, or the evaluation class, eval class that we have, to test out how did our model perform, right? And
Mm-hmm.
then we're going to test it by looking at the shapes or the output that is generated based on the input that we provided it, right? So I think we did provided with an input of 3 randomized images. So over here, like on line 16, I will tell you what's happening. Or line 16 on the block 16
Yeah. Mm-hmm.
with torch dot no grad tensors, like we are not using any gradient descent right now.
Yes. Yes.
Output equal to model. So torch dot random. So what we are doing is we are putting in three
Mm-hmm.
images of tensor,
Mm-hmm.
image
Mm-hmm.
height and image width, and we are gonna input it inside our model,
Mm-hmm.
right? Since we have already trained our model,
Mm-hmm.
and then we are gonna expect what is the output that from those
Mm-hmm.
images. How did the model perform, and what were the keys that we looked for.
Mm-hmm.
And then once we have our output will consist of keys, boxes, and the top 5 scores it generated based on those images. That this is the classification that it sees upon when it is trying to when it is trying to analyze what those images are. So it says over here it's a box. So we have boxes that are defined over here as our keys. So I think we are looking for boxes.
Yeah, I know we are looking for boxes.
Mhm. So we are just
And
inputting three random images. Three random images. Image height with
okay,
width. Three.
three random images with image height and image width.
Yes.
And where are these image height and width defined?
Yeah, search for it. Do command F.
Mm, they should be over here, right?
Yeah. Go down. Just do command F, bro. Just highlight it and command F. That would be much quicker. Yeah. See 8. There you go.
Min size, image height. Okay.
So go up. I think it should be go. Yeah, there you go. I think you have your values over here. This is your image height.
Image size is image width into image height. I think it's defined even more above. Yeah, 720.
It's yes.
Int env image height 720. Okay, so you're saying this model dot train takes in random three images with 720p height and whatever defined width,
Yeah.
and then basically when that happens, then dummy tgt is okay. And then why is it setting over here different?
No, just labeling those tensors, I guess.
And then losses equal to model dummy image and dummy tgt.
And okay, this is our dummy image, and then that's our dummy target, and then we are gonna compute our dummy image against dummy target, and then we are gonna oh okay. So so in this, what we did was, once we trained our model, right,
Mm-hmm.
we gave it two things. First, that is the dummy image. So we gave three images, because that's a three image tensor over there, right?
Mm-hmm.
Randomized three images, and we gave it two targets: boxes
Mm-hmm.
and labels,
And labels.
right? And then how then
And what are these torch.tensor? What is this doing exactly?
so that's the tensor value that it will have for boxes.
Creation call. Let me break down. Tensor creates a new tensor. Okay, so torch.tensor, this function creates a new tensor from data you pass in, and this is the nested Python list is containing a list containing one inner list of four floating point numbers because it's a list of a list. Double brackets. The columns resulting tensor has shape 1 cross 4. One row, four columns. A 2D tensor, not a flat 1D. Hmm. The dot after each numbered 100 dot instead of 100 forces the values to be interpreted as floats, so the tensor D type will be tensor float 32. Okay, by default rather than an integer type. So the result is data dot size 1.4, likely meaning of the values. Okay, grouped together like this in this pattern, two coordinates, then width, heightish. Number commonly represent a single bounding box in one of the formats: X-min, Y-min, X-max, Y-max. Hmm. Okay, so boxes, and this is creating a new tensor of 1 cross 4, right? And why? What are these values exactly?
So that's our sample values for our boxes. That's what we are telling our model, that these are how boxes will look like.
But how does that value? I don't understand why from that value. How will the model know how are the boxes gonna look like?
So when you're detecting pixels,
Hmm.
those pixels will have some kind of value. So
Coordinate value.
right, yeah. So that gets computed inside
Hmm.
the matrix, and they will
Hmm.
have some certain new values generated, and those values
Hmm.
should be closer to this values. So that's like round. So 100 dot something, 100 dot something, 300 dot
Hmm.
something.
I see. This is a smoke test for a torch vision style object detection model. This pattern is a characteristic of faster RCNN. Written on netfcos torch vision dot model dot detection. It runs one fake forward pass to check that training works and losses come out sensible without needing real data line by line model or train. Puts the model and training mod just matters because detection models behave differently depending on the mode. Okay. Model dot inputs the model in training mode. This may matters because Rex model behaves differently depending on the train mode, eval mode. Okay. Fake RGB.
What is it saying? It's just saying the same thing.
Dummy target. Dummy target is basically the ground truth annotation for that one image, matching the format torch vision detection
Mm-hmm.
models expect. So basically,
Basically,
oh, now I'm getting it a little bit. The ground truth annotation for that one image matching the format torch vision detection models expect boxes a tensor of shape n, comma 4, one row per object. Each row x min, y max, x max, y max. Here is one fake box label the tensor of shape n, the class label of for each box here class 1 losses equal to model dummy image dummy target. Both of the images, both the image and its target are wrapped in list batch of size 1. Since the model is in train mode and the target was supplied, it computes and returns the dict of loss terms rather than prediction, something like this. Exact keys depend on the structure above. Typical faster RCNN print type losses confirms dict sanity check that you're in training code path. No, okay. The loop for KV. So basically, this is a smoke test.
yes, that's what we understood.
This is a model or train smoke test, and this is a eval smoke test. You don't need real data to test whether training machinery works. You just need data shaped exactly like real data would. Here's how tensor creation choice specifically it forces model down the training code branch. Model dot training set by dot train and whether target is not none. Passing a properly formed dummy TGT means the model can't silently skip loss computation. It has 3 channels, a float tensor. It matches whatever height weight your model config expects. Random noise is valid enough input to catch shape mismatches, D-type errors, or normalization bugs without needing to load and pre-process an actual data set. The boxes, labels, tensors test the target format, contact. This is the most important part for testing the training loop specifically. Detection loss functions to do real tensor math against 3 values, computing IOU between anchors, proposals, and boxes, indexing into class logics using labels. So this single dummy box.
like I said, representation how the matrix or tensor will look like when computed.
The boxes labels tensors test the target format, contract. Is the most important part for testing training loop, specifically detection loss functions to do real computing IO. What is IOU? Input output? No.
Where is it written? IOU.
Computing IOU between anchors, proposals, boxes, indexing into class projects using.
I don't think so. It's IOU. Like it's input output is something else.
Think of it like test driving a car on closed track before you ever take it on a highway. You don't need to. If the car handles the test track correctly, you verified the engine, transmission, and dashboard all talk to each other properly before you risk anything on a real trip. Mapping and the forward car itself, the model driving in the test mode, or model or train. Inputs and reports back instead of just idling. A fake road, cone, obstacles, a dummy image, torch, rand, meaningless scenery, but the right shape of road, 3 lanes, correct length. A fake instruction card, there's an obstacle card, there's not you're not giving it a real obstacle, but you're telling it precisely where one is supposed to be and the exact format the car sensors expect. Oh, so dummy target is basically the cheat sheet that it gives it.
Rooted only
Oh,
checks that the tensor that we are generating is correct. The shape of this tensor. If there is an error in the shape of the tensor, it's gonna throw an error before training. We are just checking, hey, we are gonna send these kind of inputs. Can you process them properly? If not, and if there is any error that is gonna happen, it will be caught directly over here. So we are only providing a sample, like, hey, this is how the tensor or the data will look like. Four by
mhm.
four, it will have like, what is the shape of the matrix? It will have 100 rows and 4 columns. So we
Mm.
have, so the dummy target, it only has only 1 row, but 4 columns again, 100, 300, 400. So over that defines the image width, image height, and width, height, and I think length.
Wait, bro, let me read this completely. Fake road cone, dummy image, torch rand, meaningless scenery, but the right shape of road. A fake instruction card, dummy target. You're giving it raw real obstacles, but you're telling it precisely where one is supposed to be in the exact format the car sensors expect, driving the course and checking the dashboard lights up correctly, and run it through and see if the model reacts the way a working car should. Lost deck, lost line, etc. Each one should be real in finite number. Need the damn, bro, the 45-minute mark was so fast.
Dude, but we learned a lot. That was good. Like I did got to know a lot about like how that model evaluation and model thing works and why are we doing the dummy target,
Mm-hmm.
dummy test out over there. Yeah, let's go, bro. Let's do lead code.
Bro, let me just understand these two blocks and then we can go to lead code.
Okay.
Because
Why are you not
then
using
we,
10 to 10-year-old analogy?
yeah, that's what I'm gonna do now. Because I'm not able to understand exactly what the basic, like, boxes. So this is a dictionary, right? It's creating a dictionary,
Okay. Wait, I will tell you again.
right?
Wait. I will explain you with another analogy. Let's say you have a factory,
Mm-hmm. A
right?
factory.
Right? You have your factory, and you are gonna
Mm-hmm.
start your production line, manufacturing line, right? Before
Mm-hmm.
sending all the inputs in, like let's say raw material and everything,
Mm-hmm.
you want to do a test run. That hey,
Mm-hmm.
how will the output come when I will send the exact materials all at once, like in a sequential manner, right? Like
Mm-hmm.
in a package, in a zip file, or
Mm-hmm.
in stack of boxes.
Mm-hmm.
What you will do is you will create dummy scenario. Dummy. You will use a sample, not dummy. You will use some samples, right? You will
Mm-hmm.
say, hey, I'm just gonna send. Let's say the raw
Mm-hmm.
materials are cement, brick,
Mm-hmm.
gravel, and
Mm-hmm.
water.
Mm-hmm.
But you need to create a concrete block. You need all of them in a larger amount, right? Let's
Mm-hmm.
say you need like we can stack them into like any array, like each element or something like that.
Mm-hmm.
For that, you will just send a sample.
Bro, wait. Can you start again? 1 second.
Okay, first tell me
Let me visualize it.
what you understood. You create that.
No, nothing. What did you say? I didn't catch it.
You have a factory,
Okay, I have a factory.
right?
And then I have an assembly line.
Yes, and then you have an assembly line. So this
Okay.
assembly line relates to your model architecture,
Mm-hmm. Okay.
right? And when your model's architecture is ready,
Mm-hmm.
or when your factory assembly line is ready, you want to test it before sending everything in.
Yeah, okay.
Okay. So if you have a factory and if you want to just do a sample test, what you will do?
I will create, like, I will start the machine or like the assembly line,
Hmm.
and then I will basically send one iteration of thing to that assembly line to get created.
And then
And
you will watch for the
yeah,
output,
yeah, I'll watch for the output.
right? You will watch for the
Yeah,
output.
yeah. I
Right?
know what that code is doing. I'm
Okay.
saying to you, like, I know what this
So
is.
that's
This is
the
basically,
same thing that we are doing over
I'm
here.
not able to understand what this means. Like, this is creating a dictionary of boxes and labels.
It's a
And,
target tensor. It's a
huh?
target tensor. So you are sending in two things. You are expecting. So
Mm-hmm.
this is your target. This is something that your model is
Mm-hmm.
expecting.
And okay, wait. So we are providing values for our box
Okay, yeah, go back.
tensor. Wait. Let me say.
Uh-huh.
We are creating values for our box tensor, right? And then we are creating
Yeah,
a label tensor, right?
yeah,
And we are giving a dummy image,
yeah,
right?
yeah.
And that dummy image is basically like three. What is three here? Like random three. What is three?
Three images. Three images we are giving.
Are you sure it is three images or three random values of RGB?
Oh, I guess no. RGB. Where, dude? Where are you gonna put RGB over here?
Bro, because this was saying something like that. Mm, The model doesn't care whether the image contains a cat or noise. It only cares that it has three
Well,
channels.
yes.
It's float tensor. It matches whatever HW your model
Yeah,
config
like, so
expects.
those are random RGB values basically, but in the shape of a tensor. That's what it says over there.
Where is it saying that?
The model doesn't care where, so how will you know what is in the image? It's saying basically it's a tensor. It's not saying, but it's saying that it's a tensor with three dimensions. It doesn't matter it's a RGB value or anything, but it's a tensor.
Yes, exactly. 3 is the number of color channels, specifically RGB. Creates a tensor of shape. Three channels, height in pixels and width in pixels. Each of three layers is an H cross W grid of random values between 0 and 1, representing the intensity of that color channel at every pixel. Layer 0 is the red channel, layer 1 is green, layer 2 is blue. Stack all three, you get an RGB image. This is PyTorch standard convention for images. Oh, CHW is PyTorch's standard convention for images.
Yes.
Okay. And then
Mm-hmm. You got it.
I got the first one, but yeah.
You will get it too. Don't worry.
This line is defining one bounding box described by four numbers. Okay. Wrapped in the shape torch vision shape 1 4. Mm, What the four numbers mean? Torch visions detection models fast RCN and retina. I expect the format X min, Y min, X max, Y max. This is box is saying top left corner. Okay. 100. Ah, okay. Imagine the image with 0, comma 0 top left corner. And this is gonna be, oh, I see. Now I get it. Okay. So basically, this is defining a box, right? And this is defining a label. And this is the dummy image on which the model will be ran. Losses, model, dummy image. The real box regression models predict continuum. This line runs one image to the model because the model is in training mode. You gave it a correct answer. The target box. Okay. It hands back how wrong the model currently is. Ah. A list containing the matching ground truth answer of the image, the box plus label. One target per image wrapped in a list. Model runs the forward pass. Okay, I think I get it.
Mm-hmm.
What else is left in this one, bro? ऑब्जेक्ट डिटेक्शन की सबसे छुपी हुई लिमिट को सेल में ये है एंकर जनरेटर. Bro, some girl is shouting like a motherfucker in that club.
Mm.
I can hear it all the way through my fucking AirPods. Okay, anchor generator हर FPN level के लिए एक size और हर size 3 aspect ratio
Dude,
mirror model.
code. Otherwise,
1 second, bro. This is almost done, bro.
no,
This one
bro.
is
Like,
like,
otherwise, I won't do complete that shit or that shit.
bro. What is this tantrums?
What not? What tantrums, dude? You only said we have to follow. Now, fucking follow it, brother. Fucking follow it.
Let me see which one today. Which one you need to do today? Rotting oranges.
Oh, I think I do remember recall this. Let me see if you. Oh, again the Matrix strikes again. Oh,
Yeah, bro. Because this is what robotics
this is easy, bro. This
come.
is, I think you can do it. You can do it
I
without.
can do it.
Yeah, you can do it without my help, bro. This is the same question that we did yesterday.
Are you sure?
Yeah, bro. It's easy.
Because I didn't complete the question yesterday. I was fucking stuck at this part. Oh no, this one. This
Like,
one.
it's the same thing that we did yesterday. Rotten oranges. If the orange is rotten, then mark it wrong. Change the value. It's like the same.
Let's try.
Yeah.
You're given an M
Okay,
cross and grid where
I will say first copy the directions from that code. I don't want you to write. We don't want to write the directions again. From that code,
what direction?
copy the directions. Like from the other code, copy the directions.
Bro, wait, let me read. I know what you're
That
trying
is
to
the
do.
question. I can see it right away. Just copy the fucking directions, dude.
I know, bro, but let me fucking first read
Yeah,
the fucking
copy that. Yeah,
question.
copy that. Yeah, okay, okay. Then you can keep reading it. Yeah, copy that. Yeah, do it.
Yeah, you are given an M cross and grid where each cell can have one of three values: 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes a what? Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return. Okay, 2 is representation of a rotten orange, 1 is representation of fresh orange. Okay. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. Every minute, any fresh orange that is 4 directionally adjacent. Any fresh orange that is 4 directionally to a rotten orange becomes rotten. Okay, so grid is 2, 1, 1, rotten,
Okay, got it. Yeah.
1, 1, 0, 1, 1, or 2, 1, 1, 1, 1, 0, 0, 1, 1. Okay. So minute 1 is going to be, it's going to do in 2 directions. Okay, like this. And then this is going to spread like this. Yes. And this is going to spread like this. Okay, so it's going to basically. Return the minimum number of minutes that elapses until no cell has fresh orange. This impossible. Okay. 2, 1, 1, 0, 1, 1, 1, 0, 1, -1. Explanation: the orange in the bottom left corner is never rotten because rotting only happens 4 directionally. Since there are already no fresh oranges at last minute, answer is 0. Okay, 0 and 2. Okay, I got the question. Now, for the logic, let me write.
Yeah.
Don't interrupt before I finish.
No, I'm not saying anything. I'm on mute. you can solve it on your own. Or
Okay. What would I do here? Mm, what the fuck? Okay. Okay. RNC Orlando. Okay. Now, um, fresh orange or two representing a rotten orange. If in grid no two, return -1. NR, comma, C is equal to I plus Newman C plus mhm, F what was it? NR mm, 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 mm. Mm, mm. I J in direction. This is how they're gonna move, and F and R, comma N C. Let me going to check. each iteration will be stored in a variable. Now initialize final or counter. FNR comma NC.
Dude, what the fuck are you doing?
Bro, wait. I've not completed anything.
Dude, I know you're gonna take eternity. Okay, fuck it, dude. That's it. All right. So,
One second, one second. But I know the complete logic.
okay, so it's been 20 minutes, bro. Your time's already up. They're not gonna give you eternity for a question.
They're at least gonna give you 30 minutes, bro.
No, bro, they won't give you 30 minutes for this kind of a question. This is a medium level question. 20 minutes,
Oh yeah.
you need to complete it in 20 minutes.
Do interviews gave you to solve medium problems lead code. 20 to 25 minutes. Most technical interviews give you 30 to 45 minutes coding block.
Okay, so why is there while q for I comma j if n r comma nc? So you are not popping from the queue at any point. So you have to pop from the queue. That is the main logic. You do not pop from the queue.
I have one question, but you like over here when we do q is equal to dq,
Mhm.
does the queue automatically store all the indexes of these?
No, it won't. You have to pass. You have to pass the first value in that.
What do we pass? Q?
So you have to pass the first grid. So you have to pass on 0, 0.
What do you mean? So how do we do it? Q is equal to what?
Q equal to
Grid.
dq. Yeah. No, 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 no. Like the tuple 0, comma 0. Bracket 0, comma 0. DQ. Type DQ. No, don't do this. Delete, 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 delete. DQ.
Yeah, I already have that. Q is equal
So
to
why are
dq.
we
I
defining
added
Q
that.
again? Then so you can pass directly 0, comma 0 in that. In the bracket. Do a bracket. Do a bracket. Yeah.
Uh-huh.
Not a small bracket. It's a tuple.
What?
Yeah, it's a tuple. Yeah, do small bracket.
Again, inside the bracket, 0.
0, comma 0.
Hmm.
That's it. And then q dot pop left on line 14. You have to do q dot pop left.
But I was in the right direction, right?
Yeah, you are in the right direction, but time's up, so that's why I said okay. And then pull out r comma c or any value that you like. Yeah, let's do r comma c since you have that. R comma c equal to pop dot left. Yeah, do that. Like on 14. Yeah, r comma c equal to q.
So R comma C is equal to
Yeah.
Q dot pop left. Okay.
Right. Now, if in this, if 0 less than, do that range bound. It's gonna be so. I will just copy that. Right, it will be quicker. Go to the other question. I will show you what you need to copy.
Mm-hmm.
Is that copy? Go down. Copy this if logic.
All this.
Copy this.
And distance also.
Yeah, we will edit it later because we still need that. So yeah. Okay.
Mm-hmm. For I and J in directions, N R N C I plus R, J plus
Remove
C.
this if. Remove this if.
Um, mm-hmm. Mm-hmm.
Right, and instead of this, what we will do what is the array name over here? Go up. What is the array name? Grid. Yeah, it's grid. So we will do grid of nrnc.
Where?
Like instead of distance, we will do grid. Instead of
Oh.
distance, we will do grid
Mm-hmm.
nrnc. And how are we denoting oranges over here? So
Rotten is 2.
rotten is 2, and okay, so we will do if equal to 1.
Mm.
Wait, okay, if this is rotten, wait, it's saying that every minute any fresh orange that is four directionally adjacent to a rotten orange becomes rotten.
Bro, read my logic first. Read my logic
If
first.
grid no index, if in grid no indexed value, we return -1. If there is no possible way of reaching the fresh oranges anymore, return -1. We are basically going to check if the value of an index is 2, then iterate in forward direction until no longer possible to move the direction of an containing block. Okay, so one thing we need to do is we need to do a pass. So go up,
Mm-hmm.
go to the code that we did yesterday and copy that block. I will show you. Yeah, this block, go up 11 to 16. 11 to 16, copy this.
I was thinking this as well. Yes.
Yeah, yeah, and yeah, paste it over here, right? And then we will do if grid.
And what is range over here? Which range are we talking about? Grid.
Yeah, grid. M equal to you. Okay, so you have an issue, right? So the thing is, you cannot define random variables. Like all your variables, you need to be unique. Like you're defining RC over here, and then if you go
Mhm.
down inside the queue, you're defining RC over there as well, right? So
Oh, my bad.
right, so you have to, otherwise it's gonna
Oh,
create.
this you defined, bro. I didn't define
I did.
this.
I thought you defined it m comma n, so you can change it to m comma n accordingly because you have defined r comma c below as well. So how are you adding r
Mhm.
comma c over here on line 24 without defining it? That was my thought.
R comma C over here means basically the index of grid one,
Then
0
where is
and
I
1.
coming from? Then where is I coming from? So okay, so you are
I
adding. So why?
I and J are over here, bro, in
No, no.
directions. They
But
are
the thing is,
directions.
okay, so you are always adding. According to your logic earlier, you are always
This one.
adding the same value. Yeah, NR. No, no. Yeah, you are always adding the same value. If we do not have any Q pop, right? So this Q is a separate logic.
Hmm. Yeah.
So you have to change I plus M instead of R comma C. You have to do I plus M.
I plus what?
I plus M and J plus N. Okay.
For R in range M.
Mhm.
And we need to change this to M and N.
Yeah, no, no, no. That's good. That's good. Now that's good. We
So
just.
for R in range M,
Oh, you have to. Okay, yeah, you have to flip it. You have to flip it. Flip it. Flip it.
okay. And then and you're defining M and N here again.
Yeah.
How's that gonna work?
So we have to fix it, right? Then for R comma C, we are gonna do R comma C, R comma C. Yeah, change 22 line 22 to do R comma C. That's fine.
Again.
Yeah, yeah, yeah. Because we did change it over there.
Hmm.
Right, and okay, now what do we have over here is a distance r comma c q dot append r comma c, right? Okay, so what we will do is we will do if grid, if instead of mat on line 16, we will do if grid
Hmm.
equals to true. Now what we are doing is we are looking for all the rotten
Rotten
objects,
oranges.
right?
Yeah.
Then we are gonna remove the distance since we do not need a q. We are doing it in the same grid,
Hmm.
right? We are going to append all the rotten oranges, right? And
Hmm.
now we will do after Q, go to after press enter after Q, yeah,
Hmm.
go back, like do shift tab, yeah, do else if grid, no, like yeah, that's fine, yeah. Uh, it won't have so the colon won't come after if, yeah, and the grid will come. Oh, okay, grid R comma C again, yeah,
Hmm.
equal to 1.
Hmm.
Right? And then we can delete the print distance queue, like we do not need it over here.
What?
Delete the print statement.
Oh.
Yeah. And then we initialize a new variable that will be called fresh on line 12.
Hmm.
That will be 0 because we are gonna count number of fresh oranges we have.
I think you're going in a wrong direction.
Dude, it's correct. It's correct. we need to count number of fresh oranges as well. That's how we are going to figure out what are the rotten, which oranges needs to be rotted out, right? Because we need to find out. So if you look at the conditions we have is return the minimum number of minutes that must elapse until no cell has a fresh orange, right? So if
Mhm.
we do not count how many fresh oranges we have left, right, then we won't be able
Mhm.
to find out if there are any oranges left, because there is also a condition where there might be some oranges that are left, right? And those orange,
Mhm.
if there are fresh oranges left, then the fresh value count won't go to zero when we're trying to rotten them out every other minute.
Mhm.
That's why we need this fresh. Since if you look at the question again, it says return the minimum number of minutes that must elapse until no cell has a fresh.
Yeah, yeah. So look at my logic. We are basically going to check if the value is indexed this, then iterate in four directions. So if we find that one of the index values is 2, then
Mhm.
we iterate in the four directions with
Mhm.
a for loop, right?
Yes, yes.
Okay. And then in we go in the first direction. If we see the thing is 1,
Mm-hmm.
right?
Mm-hmm.
We go back and then we basically append that value in some sort of a queue,
Why do you want to go
right?
back if it's one? You just rot it, right? Just rot it. Why do you want to go
Yeah, I
back?
wrote it, but you cannot count that as 1 minute,
That would be counted as a minute. That's the logic over there.
bro. Wait.
Yeah.
Look at this image over here, right?
Mm-hmm.
If you are going in one direction, right, you are basically, because what the logic says over here is it will go in four directions at once.
Mm-hmm.
So that's why if you are rotting two oranges, that is still going to count as 1 minute.
Mm-hmm.
That's what I'm saying.
Oh, okay, okay. Yeah, makes sense, makes sense. So what we can do is, we can run it. We can
That's
change.
why your logic will not
So we
work
can
over
do
here.
it. Okay, I got it. I got it. What we can do. Okay, okay. So what we will do is, we will do two things. We will initiate. We will do a for loop inside the queue to iterate. Okay, what we'll do? Okay, do on line 24. Do while queue. Yeah, and
Mm.
inside it type and fresh, like while queue, like on while queue, like after queue.
Oh,
Yeah, and fresh.
and
Yeah, and then yeah, press, go outside the colon and then press enter. And now we will do for underscore
in range.
range, and then we will do length of the queue, because you said that we need to go in all four direction and all at once, right? So
Yeah.
length of the queue,
Hmm.
right, colon, and then yeah, correctly indent it out. Yeah, like correctly indent it out first. Like the indentations are wrong for from line 27, 28 till counter. Yeah. Okay. And yeah, there we go. And on line 30, we delete the counter and we do grid of NRNC, and then we are gonna rot that, like not in this manner. We need bracket that matrix NRNC equal to 2.
Hmm.
And then we will do enter, and then we will reduce our fresh orange count by -1, and then we
What
will
was it? Equal to -1 or -1 equal to 1?
minus equal to 1. That is correct.
Okay.
And then we will do enter, and then we are going to append. We will do like to queue. We're going to append this grid for exploration.
Dot append, right?
Yeah, and then inside that we will do again NRNC in tuple. NRNC. No,
Grid NRNC or
no
just
NRNC. So,
NRNC.
when we are doing BFS, we are gonna give the coordinate, never the value.
Hmm.
Not the we need the tuple, like the one that we did for the q dot append above on line 80, like that. Whenever I say tuple means a bracketed one.
like
Small.
this.
Yeah, this is a tuple. And then what?
Mm.
Okay, so we have this, but we forgot to define one thing now. We have to count the minutes. So
Yeah,
we'll do min equal to 0, like a 20 line, define a variable at a line above a while, like outside it. Yeah.
bro, that is what I defined counter for.
Okay, why are you defining it as an array then?
My bad.
Yeah. Then 0.
Zero.
Yeah. Okay, yeah, that makes sense. Now go down and then press enter. Yeah, bring
Mhm.
it outside the for loop. Why? Don't increase the counter inside the for loop. It's gonna outside. Like yeah, outside.
But it's outside only.
No, like you have to move it more outside. There we go. No, that's
Yeah.
a tab once. Yeah. Now do increase your counter. Now yeah. Now we will press enter. Move back. Shift tab. We'll do return minutes or return counter if fresh equal to 0. If our fresh goes to 0, that means there are no rotten oranges left now.
Mm-hmm.
Else -1.
Mm. But isn't it running in an infinite loop?
How is it going to run in an infinite loop? We are
Let's
popping on
try.
a queue continuously, right? Let's try. We'll see where it breaks. Oh, it's not running. Copy the code and reload. Copy the code once.
It's running infinitely, bro. That's what I was telling you.
No, dude. Is it? Okay, run it. Yeah. If it runs infinitely, it's gonna throw an error. There is an invalid syntax. So go up and elif. So remove the se, yeah, and do if and put
Mm.
the grid,
But what?
put this grid next to that elif space, and then do colon after one, and then press enter, and then do fresh plus equal to 1. That's what we are missing. We are not counting number of fresh. Yeah. Okay. Go down. Okay, you have somewhere int. Okay, so you are putting int somewhere. Go to your queue. Go up. There is some issue with, I think, Q. How could you go down? How do we have integer? Go down. Go down. Yeah, print q online to, like after colon on for loop, after colon on for loop. Yeah, print q.
And what you?
Yeah, print q. Let's see what's happening. Where did we fucked up? Go down. How
DQ00.
how the fuck are we getting integer? Wait.
Is this
Mm.
correct?
Yeah, that's correct, dude. That's definitely correct. That's the starting point for it, I guess. Hmm.
Why is it saying line 68 and driver solution.py? What is this?
Like it's the internal library. That's their internal library. We don't have to worry about it. How is int object? How the fuck are we getting int object? Okay. How the fuck are we getting int object? Go up, go up. We'll see. Print. We are printing the queue, and then we are getting. Is this coming in length of queue range for I? Print length of queue. I think there's something wrong with length of queue. I guess print length of queue.
Where?
Yeah, instead of queue, print length of queue, like on line 26 only. Go down.
3.
What the fuck? Go down. What the fuck is happening? Why are we getting? Oh wait. Why are we doing I plus M over here? Yeah, line 29. Line 20.
Direction.
Yeah, do that RC. Change it to RC. Yeah.
Oh, shit.
Yeah. And also I think if you go up, remove that 00 since we do not need it anymore. We are gonna initiate it.
This one.
Yeah.
Initiate what?
And we are directly initiating it from. Okay, the
From
one.
what?
Hold on. Go down. While queue for range q dot. Oh, we are already appending the queue from over here. Go up, go up. Oh, yeah, that's on line 18. We are appending the queue. That's
Yeah.
why. Yeah, that's why we do not. So that was the initial value that I had planned. That okay, this is to make sure that our queue is never empty when starting. But now our queue is not empty because
So this is the, I can reuse this, basically this logic. Every
yeah,
time I am trying to fill my queue.
yeah, yeah. Like if you have a question similar to this, like rotten
Mm-hmm.
oranges, where you have to figure out first, hey, let me explore and figure out
Mm-hmm.
what is over there that is not rotten.
Mm-hmm.
So this gives you O M cross N complexity.
Mm-hmm.
Because first you're doing a read first search and then you're doing a breadth first search to make sure you want to change the value that. Try running it, it should now run. There we go. Bam. So do you understood what we did and why we did and how the logic from that question kicked in over here?
I understood this part. And then we are calculating the number of fresh oranges.
Yes.
While Q and fresh.
Yes.
Over here, while Q and fresh means what? While they are valid.
Yes. Yes.
What does valid mean over here?
Valid means the value is not -1 for fresh, and the q while q is not empty. That means the value is not until 0 for
Okay,
one.
so
Yeah.
what if value of fresh would be if value, like if we come back to this after this loop ran,
Uh-huh.
right? And we come back to this while loop, and here we see, okay, fresh is 0 now.
Yeah.
The while loop will be exited and we'll come over here.
Now we will come to return.
Return, my bad, yes. Yeah. And for similarly for Q, if Q is empty,
Mm-hmm.
we'll come to return.
Yes.
Okay. And then
No, 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 no,
for,
no, dude. If you are giving me OR conditions, it needs to be both.
yeah, okay, it needs to be both. So
It needs to be both.
if the fresh is 0,
Yeah.
we check if there is something left in the queue.
Yeah.
Okay.
So if either of them fails, we exit.
Hmm.
You
If
understand?
either of them fails,
Yes, we are looking for the failure. if either of them is
Okay, 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 and okay.
right, if either of them is not true, we are not doing.
Mm-hmm.
If either of them is true, then we will pass. So we are trying to get into the loop. That's a barrier. So it's saying that to get into this while loop, you need to have two conditions
Mm-hmm.
true. That is
Mm-hmm.
1 1. Then only you will get 1. In OR conditions, you will, if you do 1
Mm-hmm.
0, still you will get 1, right?
Mm-hmm.
That's the
Mm-hmm.
difference. If you have 0 0, then you will get 0.
Okay.
If you have 0 1, then you will still get 0. That means you are not allowed. If you have 1 1, then
Mm-hmm.
only you will be allowed to go inside the while loop. So that means that the queue needs to be valid as well as the fresh needs to be greater than 0 for it to go,
Mm.
right?
Okay, so now for we are initializing a for loop for dash in range length of q, and length of q would be here. Basically, if we are doing this one, length of q would be 9,
So
right?
length of queue would be the current length of queue.
Yeah, it would be 9, right, for this one.
Why would we? Why it would be 9? It would be the whatever the length of queue that you have generated from 15 to 20. That
Yeah, I'm saying if, for example, if we are doing this one, I'm taking an example.
yeah.
Like for this one, let's say, um, where the fuck?
So the length of queue will be the number of rotten oranges.
Okay, let me then understand. For R in range M and for C in range N, if grid of RC is equal to 2, Q dot append RC, right?
Yeah.
So this is gonna be 1. Okay, so it's gonna be just 1
Hmm.
for this one because there is only one rotten orange over
Yeah.
here, right?
Yeah.
And then else if grid of RC is this, we are okay. Then we are counting fresh. Okay, okay, okay. Now I get it. And now while Q and fresh. So for dash in range length of Q. Now length of Q is over here 1,
So length of
right?
queue. No, 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 dude. The length of queue will be the total number of rotten oranges that you have.
Yeah,
Okay,
that's what
yeah,
I
you have
said.
only one. Yeah, my bad, my bad. You only have one rotten orange. That makes sense.
Yeah.
Okay, so what this? Okay, yeah, yeah, go ahead.
Wait, let me iterate. Yeah. Then R comma C is equal to Q dot pop left. Okay.
Yeah,
So whatever you pop out of the Q is going to be stored in R comma C.
yeah, and that's a rotten orange.
Yeah. So that's gonna be the index R comma C.
Yeah.
And then for I, J in directions,
Mm-hmm.
the directions are 4 directions as mentioned above. And then NR and NC is going to be I plus R and J plus C. So whatever you popped out,
Mm-hmm.
so that is going to be basically over here 0 comma 0, and 0 comma 0 is going to be put over here with I and J in directions, which is going to be 0 comma 1. So NR and NC are going to be 0 comma 1 over here. So if 0 and NR and okay, and if these both conditions are satisfied and grid NR&C is equal to 1,
That is not rotten.
that is not rotten. And so you, if that is if these conditions meet, you convert that fresh orange into a rotten orange over here,
Yes.
and then you decrease the count of fresh,
Yes.
and then you append
That rotten orange
uh, the NRNC.
into the queue.
Why are we appending it in the queue again if
Yeah,
NRNC is going to be rotten?
now it's gonna spoil
Oh, now
otherwise.
it's rotten. Now this is
Yeah.
rotten.
Now it's rotten, right? So we need to append it.
Okay. And then we increase the counter by 1 to add the
No, we don't
minutes.
increase it. We will increase once that complete for loop is done. So right now the for loop is empty. That's why we will increase it. But until, let's say you have two rotten oranges, so until the for loop is iterated 2 times, that means
Hmm.
2 minutes have passed. So the
Hmm.
for loop defines a minute.
Yeah, that's what I'm saying. When we'll come here,
Yeah.
when we'll be here, then. once the queue is appended,
Yeah.
the counter is going to get increased or not?
Yeah, the counter will get increased once the for loop is completed. Like,
That's what I'm saying. That is what I'm saying.
dude, like once you have reached the end of the range of the for loop, that's what I'm saying.
Oh, end of the for loop range.
Yes, end of the for loop range, not every after every other for loop. End
But
of the,
that when length of queue is 1,
yeah.
right? Then it will end after this, right?
Yes, yes, yes. It will.
That's why the counter will increase by 1.
Yeah.
That's what I'm saying.
Yeah. Oh no, I was just making sure that you are understanding that that for loop defines a minute. So if the range
Yeah.
goes to 100, it's gonna iterate until 100, and once the for loop
Uh,
completes, then the
mhm,
count, then the
mhm.
minute will count.
Yeah, that is the basic logic about
Yes.
yeah, spreading the rotten oranges in all 4 directions.
Yes.
Yes. Yes, sir. I get the question. Yes, I get the code and I get the
This is like,
question.
you know what, this is like how there are patterns. As soon as I saw it, I told you to start copying it, right? Just copy that part, just copy that part, right?
Mm,
Because like everything, every other question that you see in lead code is it's always a fucking pattern. And then you just
mm,
play around with it, and then once you get to understand, okay, oh, I think I have done this question in that point, and then I can maybe, use that block over here.
mm,
This is what I was talking about, the syntax. So as you can see over here, for directions, we already have to do that directions, right, array. For going into
mm,
all the directions, we have to use that for loop to make sure that we are iterating all over the oranges or all over the grid ones. We need to do
mhm,
a single traversal as well, right? Apart
mhm,
from it, the queue remains constant. There was a tweak regarding, okay, what we need to do inside once we have explored the BFS, right? So
mhm,
this same applies to DFS approach as well. I think DFS uses
mhm,
stack approach where you have to keep stacking and then use recursion to make sure that you are
mhm.
going to the depth.
I see. Let me see if we have any DFS.
All right, bro. I got a. Oh wow, damn! DoorDash refunded the whole thing. Easy shit.
Why?
Dude, I ordered something and then it was not as expected. That's it.
Hmm.
All right, well, let's end the stream. I got a leak.
1 second. Yes. एंड में प्रोडक्टिव हो ही गई थोड़ी स्ट्रीम